Oh, record to the cloud. Cool. That's interesting. All right, I'm recording. Okay, well, welcome everybody to the July 2020 Canberra ADUG meeting. How about that? That's the official bit's over. Okay, news from me. I'm just doing a course at uni, so not actually doing any meaningful work. Don, what are you up to?
Ditto. No meaningful work unless you regard planning for the next semester of C# programming meaningful work, but no meaningful Delphi work.
Okay, well that's good. I mean, what was it? I think my teachers at high school used to say, proper prior preparation prevents piss poor performance. So
it's
based on that, tonight's presentation might be a bit dodgy.
Yeah, it's proper planning prevents piss poor performance. That was when I was in the army. That's what it was.
Yeah.
Yeah.
Well, in real estate, they all talk about location, location, location. And in teaching, it's preparation, preparation, preparation.
Yeah, okay, fair enough.
And then when you're doing Delphi programming, it's what's going on here?
Yeah.
RTFM.
Yeah, no, WTF. More like.
All right, Hill, what are you up to?
I've been trying to get a couple of pieces of equipment going. I realized I'm pretty much always asking the same questions of Arduinos. So I've written a sort of a stub that will accept all the questions that I generally ask Arduinos and return an answer in a standard format. So that then when I write my Lazarus programs to speak to the Arduino, I only have to ask them formatted questions and accept formatted answers. So that should hopefully save me quite a bit of time getting hardware stuff going.
Cool.
Yep.
Yeah, that sounds dangerous. Sounds like you've written a library.
It's not very big, I can tell you. What's an Uno got? It's like 32K or something.
Yeah. Yeah.
All right, okay, well that was really quick. Quick run around with the news. All right, so what have I got? All right, so here's my list of news. I'll start sharing my screen. And can everyone see that?
Yep.
Okay, doesn't show you in the screen as well, does it? I'll stick you all over there. All right, so obviously, as Vincent said, patch 2 for Rad Studio is now available. I guess I'll put all these links on a somewhere so that we can all see them. I'll send them out with an email to the ADUG group. And it has information on how to download and install, blah, blah, blah. Haven't done it myself, but seems, and there's a list of some of the fixes.
Interesting, it doesn't list the new bugs.
They're features.
Oh, right, yeah. Yeah, I did have some trouble installing it, but that get it download thing failed for me the first time. I tried it again and it worked. So
yeah,
a lot of people are getting the corrupt download problem with it as well.
Okay.
So if it doesn't work first time, try again.
I think it's important is you need to have patch 1 installed first.
Yeah, I did. Yeah.
Yeah, so anyone who's watching the video will know that. Okay, so that's not very exciting. Couple of bits of news from ZDNet. And Microsoft's pulling the plug on.
Here's the latest news.
On Windows. Is somebody talking on my screen? No.
Somebody got OK Google or something going.
Political heat due to its ties to China.
Yeah. Do you want to mute your microphones, guys?
Sign a petition which could ban the app in the US. app is supremely popular with millennials and Gen Z. However, according to the petition, its ability to access material and data.
It might be from this machine, who knows? Oh dear. All right, good. Yeah, you can still run PHP on your Windows, but they're just not going to be making distributions, I think. There we go. This message meaning Microsoft aren't going to produce official builds for PHP 8 onwards. So I don't know how popular PHP is these days. I still see a few adverts.
It runs pretty much most of the internet.
Yeah, I mean, and that's
WordPress.
WordPress is running it, yeah. But I don't see as many PHP adverts, although I guess I'm not looking for them for positions as previously, but there's probably more PHP jobs going than there is Delphi jobs. The other thing that may be a little bit more closer to us is Australian Broadband warns of possible speed cuts. This is on your connectivity virtual circuit. So apparently with COVID, they've sort of, NBN gave everybody a little bit of a boost, a bit of extra bandwidth, and we've all been using it. So as a result, usage has gone up. Although these look like they're going down, doesn't it? Okay. Average download per service by current speed. Okay, this is probably when everyone was working at home, and now we've a lot of people have gone back to work. That's but anyway, so they're going to charge people extra money, the providers, and that means that eventually we'll get charged extra, I'm guessing. Cool. Anything else? No, not from the news that we could find. So we'll just get rid of that. So just lately there's been a little bit of correspondence from Lachlan regarding one of his clients who wanted to change a Delphi program into Python. And I just so happened to have been doing some LinkedIn Learning Python courses, and which I'm glad I did, because it turns out that we're using Python in this big data course as well. And because I've been working with Python, I thought, well, I mean, I can just show you a little bit. I shouldn't say working with Python, because that implies I know what I'm doing, and I'm still in that very early stage when you're learning a new language, where you're sort of thrashing around just trying to keep your head above the water, and things happen, and it's taking you 3 hours to get it to happen, so you don't stop to work out why it happened. You just move on to the next thing. But Python has impressed me in terms of its ability to manipulate data very quickly. I'm sure it's used for other things apart from just big data type situations, but you know, this is where my experience is at the moment. I can't make any comment whether Lachlan's Delphi program would be you know, suitable or not suitable for migration to Python. I think it's all a matter of horses for courses, and you know, Python's certainly got some things that impressed me, but you know, I'm easily impressed. So a list of the sites of where you need to get stuff would be Python. I think that's probably one of the first things you need to download. If you're running a Mac, it's probably already loaded, both Python 2 and Python 3. Version 3 is obviously the latest one, and I think they're on to 3.7 or 3.8 at the moment. It's the only thing on that screen. Yeah, latest Python's 3.8.5. It was pretty easy to load up on my Mac. I can't remember exactly all the steps. I think basically you just down and load an image and you run it. we're going to be using a bunch of extra libraries with this, and we're also going to use an IDE type thing, which is called Jupyter Notebook. So Jupyter has a bunch of things, and Jupyter Notebook is an IDE basically for open source, blah, blah, blah. You can do all sorts of things in it. Quite a few Python people are used it. I've come across this in one of the LinkedIn learning courses, was used Jupyter Notebook. It seemed to be a little bit more complex to load under Windows than on the Mac, but if you're interested, then I'm sure you can find there's lots of YouTube guides and installation guides as to how to do it. In fact, I've got a link here on a blog that somebody put out, how to load it under Windows. We're using a couple of other additional libraries. We're using Pandas, and there's another library that I haven't even shown here, which is Numpy. That's which has got a whole bunch of numerical type functions and functionality. Pandas seems to be a library which has got data structures. So you do a lot of manipulation of data in memory. It'll load data into like huge arrays inside memories, and has functions that very quickly perform data analysis or computations across those. So we're going to use that today. As I said, Numpy is another one that I should have put up on here. Matplotlib is a library which I believe is similar or like the Matplot language. I have no experience with that, with Matplot, but Matplotlib allows us to create some sort of very quickly create visualizations and document some of the information, you know, some of the big data that we're going to play with today. On top of Matplotlib, there's another library called Seabourn, and as you can see, their pictures are a little bit prettier. So they've kind of wrapped their functionality around the Matplotlib. So I think I've got a couple of little, a couple of graphs based on those. Okay, so today I'm just going to run through a couple of examples. I'm getting some data from this site, which is one of the American government sites to do with weather. And there's a couple of files. I've already downloaded them because they take a little while to download. One is this ground stations file, which is basic information about all the different weather gathering stations around the world. And there's quite a few of them, as we'll see. And there's quite a few in Australia, including, I think, the Rudy Hill RSL Club was gathering data for them, and lots of little places, and probably little tin pot stations here and there. But I did have a look at the Canberra airport weather, and I think that's the one that we're going to play with today. And that only seemed to have information up to 2010, so I'm not sure what the story is there. Okay, once you have Jupyter Notebook and everything loaded on your computer, or I guess I should just do very quickly. If you could say Python 3, this is a little bit like Node, that you can, it just puts you into a command line sort of thing where you can just do, you know, print, you know, hello. All right, how about that? There we go. Now, what I don't intend this to be is is a lesson on how to program in Python, because if you're interested in that, you can go off and learn it, and much better than I can show you. So I'll just get out of there. But the one I'm sort of more interested in is running Jupyter Notebook, which basically runs like a little server, opens up my web page, and I can go down to, here we go. When I moved onto the Mac, I just put all my Delphi projects. I just transferred them over from the PC, so that's why they're under Rad Studio projects. But now it's everything's under here. And let's go into Python. There it is. And okay, I should say this Python data analysis is one of the LinkedIn, these are the 2 LinkedIn courses I've been doing on LinkedIn Learning, of course. And most of what we've got today is from this course, not the Griffith course. So with Jupyter Notebook, you can see we've got this Python NB file. It's a pretty cool sort of way of doing things. Anyway, we'll just go through step by step. So basically, all of these could be all combined into a single Python program and run as a script. And who have we got? No one. Okay, I thought saying somebody's arrived. So I'm just going to import the libraries, some of the libraries we're going to be using. This is that Numpy or Numpy, Pandas, Matplotlib, and I think I'm downloading the Seabourn a bit later on. So if I just press Shift Enter, it will run that command, and it's not outputting anything. This line here is to make the plots appear in this screen, but I haven't been able to make them appear anywhere else, so I don't know why I'm doing that. So to download a file, you'd use this command. I'm not going to do it because it'll take so long, which is urllib, which was one of those libraries, of course, request, put in the URL and put the file name and Bob's your uncle. And we can actually have a look here, and we've got the all stations CSV. Well, that doesn't look good, does it? Oh, sorry, stations.txt. There we go, 9.9 megabytes. So I'm not going to run that. If it did run, you'd get this output. So basically, this is a fixed format file, and this is the column definition, which is in the start of the file. So we're going to parse this file, and this is just telling us which columns out of the data we're going to grab and what the names of the columns are going to be. This is actually telling us the data types as well. But and then all stations, when that runs, it will print the top and the bottom of that data set that's been brought in. Notice this is a Numpy function. So I'll do Shift Enter, and I don't know if you saw, but that 2 had turned to a little asteroid, which means I'm busy, I'm doing something. So here we go. It's brought in the array, and we can see, it's an array, square brackets, we're all familiar with that. And this is basically the first 3 entries and then the last 3 entries. If we do the next command, which I've already done, I went through and cleared all my output, but basically it's telling us we've got 115,000 entries. So it was pretty snappy to load that, for an interpreted language. Okay, so this is all we need to do. Actually, we don't even need to do all of that. We only need that middle line to plot, and this is in Matplotlib, a graph of all the stations, and I want to have the longitude and latitude. That's the X and Y. So you can see within the file, the first name is the ID of the station. We've got, is that latitude and longitude? I don't know. Yeah, it must be, because that's the way they've got them there. And then this line is just telling us how big it's going to be, and this is going to show it. Now, if we went back at the top, we imported Numpy as ND and the Matplotlib PyPlot as plot. So this is that's where that is. So let me just run that, and it's thinking about it, and I thought, wow, that's pretty cool, isn't it? Let's just plotted it. So each dot is a weather station. Now I've made them small. That's the size of the dots. If I made them, you know, make them a bit bigger, it makes it a little bit more, fills in the gaps a bit more. Now, because we can have a look at Australia, we can have a look here, and by means of trial and error, I sort of worked out that we're basically within these coordinates, and we can print the length of Australia. So what I'm doing here is I'm saying, create yourself a new array out of all stations with this criteria. So, and then I'm going to print the length of how many records that is, and then we're going to have a look at them. So we can see it's from that 150,000, nearly 17,000 stations, basically within that that area. I think we'll probably find that there's some in the ocean, and doing a very similar sort of scatter plot diagram of the same. You can see we've got a few outliners out here, and you know, it makes it a bit easier to see. All right, so that's pretty cool. Okay, so what this is going to do is, this is a NumPy. I'm going to create an array of random data, normal distribution, I guess, in range 1 to 4. So we're going to end up with 4 arrays of 100 elements each, just as dummy data that I'm going to use for the next little while. So there's our dummy data. Now, here we're going to do, we're just going to do a box plot of the data, and I don't know if you're aware of a box plot. It's something I just learned from this course. Basically, you've got the first, second, and third quartiles. So the second quartile being the median value, the value that's in the middle of the range. The first quartile is the one that's in the entry that's in the first quarter of the range, and the third quartile is, believe it or not, the 75% one. It's showing us these whiskers, which are 1.5 times. Well, that's not right on that, is it? Okay, that must be using a different definition. Usually have the whiskers 1.5 times this distance. I suspect they might just be shown as the outliners in this. All right. Okay, well, we only use that data for one thing. This Pandas library has this concept of data frames, and which are built on the NumPy arrays. And so we'll just get straight into it. So this is creating a, well, this is actually a dictionary. This is a Python dictionary. So that the key is, this is the key is company, and this is the entry, which is an array associated with that dictionary key. Same for sales and person. So these are just made up values, and what this is going to do is, using the Panda library, is going to turn this data into a data frame. So this first line does it, and with Python, the last line, basically, if it has a value, it displays the value. So this is showing us that we've got 3 rows, 100 columns. Because I didn't do this, did I? I didn't set that one up. Okay. All right, that's a bit better. Yeah. All right, so you can say, all right, well, that's pretty, you know, nothing too fancy about that. Okay. But imagine we start looking at millions of rows. It's pretty good. The information on this data frame is that we've got the 4 columns. Obviously, there's the column name 0 to 3. Now, there's not null counts, an interesting thing. With this particular data set, I don't have any null values or missing values in there. But if I did, this would tell me how many were not null. And this is telling me it's an object. So the first 2 the strings are treated as an object, and the others are 64-bit integers. We can do a describe on it. And what this does is this will do a very quick set of mathematics on any of the numeric fields. So there's 8 sales, 8 costs, gives us a mean, standard deviation, min. These are our 3 quartiles, and maximum and minimum. So, and if we'd rather see it this way, you just say dot transpose. You can do group bys, which is a bit like your SQL group by. And if I'm group this by company and describe it, we've got the same kind of thing. So Facebook, Google, going across this way for sales and costs.
Sorry, Steve, can I just ask you about the display formatting there? Does the IDE know something about this to display it, or?
I suspect that this displaying would be in created by the Pandas library, because if I go and if I just display this data, this is a basic Python display. You see, it's pretty, you know, basic,
Yeah.
you know, 80 column card type output, you know, on your teletype.
So I guess, so is this data frame thing then basically some sort of formatted output, basically? Is that what it is?
It has a formatted output, but that's not the main purpose of it. The main purpose is it's so that you can do these fast calculations across large data, in-memory data sets.
Okay. It kind of seems like it's put out HTML there, you know.
How it does, I don't know.
Yeah.
I could run this in a terminal and see what it outputs. That'd be interesting.
Yeah. Anyway,
no,
just a thought. Yeah.
Look,
it just seems a bit magic.
Yeah, at the moment, this is all magic to me, you know. There is libraries, I think, for creating websites and things in Python, but, you know, I've got no idea what they are or anything.
Okay. Right, sorry, carry on.
Okay. All right, good question. Okay, what I'm going to do here is I'm going to create a thing called sales and costs, which is going to summarize, and it's going to, this is a tuple in the, as how Python shows a tuple. So, which is a way of just showing us the two entries. So there's the costs and there's the sales. No big deal, nothing fancy. So I'm going to plot these now. So what this is, the fig, and the fig size means it's going to be 10 by 5. Supposedly this is in inches, but, you know, with anything on a monitor, it's, you know, it's just relative, really. So what am I doing here? Okay, I'm setting some axis limit. So the Y is going to be between 250 and 600. And basically I'm going to plot the sales, which is, which one was the second one? I'm going to plot this data frame, and LW equals 2, no idea what that is, in blue, and I'm just going to output some labels in blue so you can see them, and set color blue. And then the second axis is going to be, this means on the other side. So our y-axis will be on the other side with the same scale, and we're going to plot them in red. All right, excitement, enough anticipation. Let's see how it goes. So that's it. All right, pretty simple. It's only a little bit of data, but just to give you an idea of the sort of things that you can do relatively quickly to get something that you can save out. And yeah, I guess what I should say is, I might do it later because I think I've probably shown it later. All right, let's go into Seabourn and use a little asteroid there. We're going to do a box plot, and you can sort of compare that one to the sort of box plot we had back up there. Looks a bit nicer. I think they've just spent a bit of time, put some smarts in to automatically, you know, make them look a bit nicer out of the box without even changing the palette. All right, so we're going to go back to the weather, and this is, so we're going to start playing with some bigger data now. So what this is that all stations, that list that we did at the start, and I'm doing a thingy where any of the stations have a name called, which contains Canberra. So let's have a look what that gives us. Gives us a fairly small array because it's only included these ones. Now, the one I did download, and this is the link, is 14, which is the Canberra airport comparison. And I downloaded it into a file called Airport Daily. It took it quite a while. So again, I'm not going to download that again, but that's now in this file here. If you consider it's only a small file, I wonder whether I downloaded the whole lot. Again, this is the format of the file, and I'm just going to import that. And I thought I'd call this W for, I don't know, Agent W, whatever. So that's a bit of the start and the end of the data. You can see the dots in between the entries here. And I'm going to turn it into a data frame. So that W is taking that array, stick it into a data frame, and it does the same sort of thing. It shows me the start, the head and the tail. And we've got 2,588 rows, not that many really, going back from 1939 to 2010. And I suspect I've cut it off early when I was downloading it. You can see we've got a whole bunch of entries that are 9999, or maybe they stopped paying them or something, I don't know. So these are obviously dummy entries. And what it's saying is the maximum temperature on the 11th, and on the 1st of the 11th, the maximum temperature was 190. Okay, these will have to be divided by 10 a bit later. So it's really 19 degrees. Not too warm for November, is it? I guess it's Canberra. All right, and from, you know, you can sort of see ... from day 22 to day 31. So what we're going to do is we're going to manipulate this data into something that's a bit easier to use. So this is going to melt, as they call it, each entry. So we have an ID, the ID, the station, year, month, and the element and a var name day and the value name value. So that's okay. Now if I do this, I'll just make that a comment and we can print it. So you can see that this is what we've done. We've created all these entries. So we've now got 80,000 records, but there's a lot of them with crap data in them, and this command will just get rid of them. So I'm going to copy this data frame, which I've called df, into itself. Well, I'll create a new version of it, only if the value is not equal to minus 99999. So one of the things I'm learning in this big data course is that first thing you got to do, well, not the first thing you got to do, but once you have your data, you've got to go through it and you've got to cleanse it, and that's a whole science in itself. Black art, because there's no set ways of doing it. You know, getting rid of nulls and maybe filling in missing variables using various methods if that's what you need to do. If we run it again, we'll see that we don't have those negative 9999 entries anymore. We've only got 159,000 nearly. Now, I don't know whether we have anything else, but again, a lot of this was out of that course and they were using it from a different location. So we're only going to keep, I don't think we have any snow entries, max, minimum, and precipitation. So again, oh no, it must have, because there must have been 80 odd entries that weren't those. Interesting. Note to self, your spare time, Steve, find out which ones they were. Right, now we're going to apply a Lambda expression. This is how they do it in Python. And we're going to create a new column called day. Actually, we're going to write over the existing column, which is day. It's called day1 value. That doesn't look right. What have we done? I think it's because I've ran this twice. Yeah, it's because I ran it twice. Let me go back to here. I did this to myself last night. And run that. So that's looking a bit better. So we're going to take the value of, this is like a map, like a JavaScript map against, so it runs this against all elements, and it's going to create a new array, which we're going to write over the top. It'll probably give me some warning that says, oh, that's not a good process to be doing, but I don't know. That's what they all say to do. We can have a look at the info on this, and it tells us we don't have any null objects and basically this many rows. Yep, the same number of rows. A day is an int, 64, the other dates are 32s. So what I'm going to do is I'm going to create a new column. I'm going to add a new column to this array, this data frame array. Think of it as an array, I guess. Yep. And I'm going to ignore any errors. It wouldn't work otherwise. Again, it gives me another, oh, I'm not sure you're meant to be doing that, Steve, message, but it works fine. So now we've got a date in here. That all looks good. And we can drop off all the elements I don't need. So all I want at the moment is the date, the element, and the value. And notice by now that our ID column is the same, so we can drop that off. On the left here, you'll see that there's an index. That could be a number, or it could have been a value. That's a unique value. Anyway, as I say, if you're interested in data frames, you have to check it all out. So now our data frame has only just got these elements. And now we're going to do a pivot table to glue them all back together again. I'm not quite sure why this says columns.name equals none, but off we go. And now we have our data put back into 26,000 rows with 3 columns. Notice that we now have a bunch of NANs in here, and if I create a thing here and I say df.info, it'll tell us how many are non-null. Temperatures are 10 times too big at the moment, so we can just do a simple divide equals 10. And now that's done. And I was playing around with this late last night. I decided, oh, I might put a year back into it. So there we go. I was going to say, hopefully I haven't stuffed up the whole demonstration. I've taken that out only because I thought I'd play with the readings from 2001, and that would be an easier way of pulling it out. So the data frame, and this is my selection for year, equals 2001, because that's the Space Odyssey, and min, max on precipitation. Okay, so if I didn't do this, I'm pointing at the screen, but you can see it with the cursor, I guess. If I didn't do this step, we would also have the year in it and date. Let's do that. So there's our data from 2001, 365 rows. Now I'm just going to do a, because I don't know if you recall when I brought in Seabourn, I brought it in as SNS. That seems to be the standard that they use. Because that is using the Matplotlib underneath, you still have commands. Your commands still work on the plots. So this is basically initializing our plot and giving me a plot size of 14 by 6. And I'm just going to print a line print plot with this data. And there we go. So you can see it's a little bit prettier than the straight out of the box Matplotlib. It's automatically giving me little colors. It's giving me a title at the top, and there is a very simple command, which if you give me 2 seconds, I'll have a look for. And yeah, nah, sorry, gone somewhere else. There's a very simple command that you just say basically ax.save file, and you can save it into a PDF file or a PNG file directly out of here, which is pretty cool. So I guess that's probably something you would want it to be used if in real life, if you put together a report for somebody of various data. This is showing some histograms of the same data. All right, so this is a Seabourn line plot. All I have to do is give it the data. This would be a Matplotlib because it's the data frames. You can just plot straight out of those. And if we look at that, this probably isn't very useful information with this particular data set. It's plotting the precipitation. So the number of days, we probably didn't change the precipitation, have we? I reckon the precipitation probably needs dividing as well, because that looks pretty high, if you ask me. The number of Okay, not quite sure. Once I finish my course, I'll be able to tell you. There's a distribution of the temperatures. So obviously, if this is a percentages coming up, no, don't know. Yeah. Interesting to see the curves, the extreme. Oh, that's sort of almost your bell curve, isn't it? It's not bad. Of minimum temperatures and an offset right with 2 peaks on that one. And I'll run this one. This one will take it a little while. Okay, what have I got? Invalid character in identifier. Okay, this will take a little while because I know what this is doing. This is creating a matrix. And you can sort of see these are pretty much the graphs that we had up there. Pretty much, not quite. These are bars, slightly different, and some distributions. So you can have a look between correlations between minimums and max, which is to be expected as it gets warmer. Your minimums are going to get higher and your maximums are going to get higher. So how about that? And there's no correlation between temperatures and precipitation. All right. Are you all awake still? That's about it. Any questions? I suspect our esteemed colleagues from the educational institutions are probably all over this Python business. Is that correct? Is anyone talking?
Unmute your microphone, Hillary.
Sorry?
Oh, there you go.
Your lips
Yeah,
are
no, I
moving.
was trying to do it with the space bar. It wouldn't do it.
It doesn't. I think it's a Mac thing because it doesn't do it for me either.
Hmm.
It says.
I was just going to say that it's strikingly similar to R, which is what I was doing.
Press and hold the space.
Press and hold. Okay. Well, yeah. So I was doing R this week, which is, as I say, is extremely like this.
Huh.
People say that Python is better because R is very memory restricted. And if you try to do big things in R, it grinds to a halt, whereas Python does it better. I could show you a couple of quick things in R if you like. I didn't prepare anything, but
Yeah, sure.
just for comparative purposes.
Okay, so
Steve, did you look to see, are there any libraries for Delphi for doing this sort of data manipulation at all?
no, I didn't because, oh, are you asking me or Hill? Or
Steve, yeah.
yes, mate. No, I didn't. I mean, mainly because these are what's being used in this course that I'm doing.
Right, okay.
So I'll stop that share and okay, you should be able to share your screen. Who can share? All participants. There we go.
Share screen. Studio. Share.
Cool.
Okay, you guys seeing this very depressing looking 4 panels?
Yep.
Okay, so your scripts all run up in the top left here. And then your console with your output goes down on the bottom left. Your global environment, your data and so on appear on the top right. And your graphing and so on appears at the bottom right. So to execute something, you can write it and save it. I find it inordinately wordy. You spend your life typing crap. It's like Linux. But it does have the advantage that you can keep it. So I can now execute the library and it tells me that I've loaded the libraries. And one of the things I loaded was this database of iris characteristics. So if I now execute that line head iris over here, it shows me the first 6 lines of the iris file. So it shows me sepal length, sepal width, and all those good things that one cares about. Irises, which I don't particularly. If I go $plot, it will tell me about the plot routine. I don't think we really care. So what we might just do is we'll start by, well, okay, we'll do it in the order they did it here. So we can plot the species and we just execute it and it shows us a bar chart of the species, which isn't very interesting. There are 50 of each, which is what we'd expect. And then I can plot the sepal lengths, and we see our 3 species there again, and we see that they have different sepal lengths. And then I can plot the petal length against the petal width. So what we kind of expect is that bigger petals, not surprisingly, bigger petals tend to be wider. And if we want to, we can plot the entire data set, which is actually kind of useful because it gives you a chance to get an overview of the whole thing. So you'll have to put up with my computer being a bit slow. But we can see there which of the coordinates and so on in the database actually make any sense with each other and which don't.
I think that's very similar to that last plot that I showed.
Yeah.
You've got the diagonals, which are the same thing, and then you've got the correlation. So obviously, like the third column across the top, you've got a correlation there between the 2 things that it's been mapped.
Yeah, presumably sepal length and petal length, which is, you know, what we'd expect. Bigger is better. So then we can plot petal length against petal width. And I'd say, although this seems very wordy, you can go in and edit things and change them on the fly. So you can reuse a lot of what you typed. So if we just look at petal length versus petal width, you get that. And then we can do all sorts of various stupid plots if we want to. We can plot cosine, exponential, norm. Now you can actually overlay these on the plot. Yeah, we can change the line type and so on. The usual kind of thing. So that's just okay. I'll show you an overlaying plots example. So what you can do is you can import all your data. You can write your code, if you want to call it that, to go with it, and then you can save it and reuse it. So this is links data. So this is literally for links cats. So when I type head, it shows me the whole thing down the bottom there. Shows me sort of the key characteristics of the data set. Where are we? Yeah. Okay, it's just showing me one line in this case. It's just pop. I don't think there's much in the links database, I think is the answer. I think it's just the number of links is trapped against the year. So we can just go hist links, and it will show us basically the number. That doesn't make much sense to anybody. And then we can do it a bit better. Okay, so that's the number of links trapped. And we can add a normal distribution. And we can run various other, we can do a density plot over it. And right, whatever that is, I forget. You can't really see it, but it did a frequency kind of thing here to show you where the data actually were. Yeah, I think that, so you sort of get the idea. It's and you can import data sets, manipulate them, and like Python, it will let you write programs to manipulate the data, to change things, to transpose things, to do pretty much whatever you like. And in fact, the course I did the other day was on mapping with it. So we were looking at we had a map of, or a photograph of ANU from the air, and then you could put a coordinate system on it. And then we had frog data that had a similar coordinate system from a spheroid. We could then plot the frog data onto the background of the ANU and so on, all the usual. So it's sort of, it's like a combination of Python and GIS, I think. It's about what it comes down to. I sort of never really got into it. It's kind of interesting, but I don't deal much with big data sets.
What's the licensing on R? That's proprietary, isn't it?
It's free.
Oh, it's free, is it?
It's free, yeah. The R language itself is free and open source. And what I was showing you there was something called RStudio,
Right.
which is also free.
Okay.
And it runs that scripting language rather like Python, but within that sort of graphical environment.
Maybe of interest is that R is built into the new versions of Microsoft SQL Server for the not the Unix version, but the Windows versions have R built into it. So you can do your manipulation of your data directly onto the server. I believe one of the other differences is with R, you can compile it. So it's compiled as opposed to running as a scripting language like Python.
But I think for all that, from what people tell me, some of my friends have worked with big genetic data sets and that kind of thing, that Python is a good deal faster. And that if you want to handle big data sets, you're better off in Python.
All right, well.
This all reminds me of a tool called Cognos. I think IBM own it now, which I used about 20 years ago to do the same sort of thing, but with sales data and stuff, you know, slicing and dicing and pivoting and creating cubes and all sorts of things.
Yeah.
Yeah.
Yeah, I think Cognos is more for reporting, like a reporting tool rather than.
Yeah, it had a bunch of like component parts that you know, different programs that you had to. I got sent on a course on it when I was working for Mars, and
Yeah,
wasn't my cup of tea, that's for sure.
I expect being IBM, it was fabulously expensive.
Oh yeah. I wasn't involved in that, so.
The good thing with R is that the whole thing is free, and there are a million packages out there. It's all supported by the users. You can do almost any kind of statistical or mapping treatment you want to if you know how to do it.
Right.
Which kind of makes me think that things like GIS, you know, say Esri, for example, that's so expensive, they're probably going to have a limited lifetime faced with something like that.
Yeah, I think, you know, was it SPSS? Is that the one that you were saying? I think they're licensing themselves out of existence. And I think there's, like my wife works for New South Wales Health in an area where they're doing a lot of research, and they're just not going to get the renew the licenses, because why not? You've got Python, you've got R, and
yeah,
it's all open source tools that you can just use, and they just work. So, you know,
a friend of mine who is a psychological profiler for the federal police, she went on this course using R to access the Facebook API, so they could download all the Facebook data and troll through it, looking for people that were likely to blow things up.
But probably the main answer that would have come up there would be Donald Trump, wouldn't it?
Yeah, you get
like millions and millions of rows of Donald Trump.
well, that's what this course I'm doing will be doing in the next after this first 6-week block. So yeah, I'll be able to tell you all about it by then. Yeah.
I just read this book called Mindfuck. It's about, what's it called? Canadian Analytica. Is that right? Anyway, it was this company that they made a business out of pulling in these sort of data from Facebook, and Facebook was encouraging them to do it. And they were using these data to bias elections, like the election of Trump and the Brexit and things like that. They were being paid a lot of money.
There's been quite a lot of coverage of, you know, TV documentary stuff and that as well. I watched a documentary about Cambridge Analytica.
Cambridge, that's right.
Yeah. Basically just completely swayed Brexit. You know, the way that, you know, just manipulate data, and they had no morals, those people, that's for sure.
No, none at all.
Yeah.
Yeah, and the only way we can fight against it is by refusing to use any social media. But even
Yeah,
so,
pretty much, yeah.
yeah, every time you buy everything, and anytime you go to eBay or use your Visa card, and COVID's made it worse because more and more people don't want cash now, and I think that's going to stay around.
Yeah.
And so everything
They've
you
got
buy is
more
traced.
data. Yeah, there's more data about everybody.
Yeah.
Every time I mean, my wife shops at Woolies, and she says, "Oh, these are on special." They were on special for her because they know she buys them. Like they know what you buy. They know your buying patterns. Every time you tap that card, the retailer is getting analytical data about you, about your shopping habits and that. I miss using cash. I miss my anonymity. I must be like Donald Trump. Can't say the word.
That's easy for you to say.
It's not.
Yeah. Well, I was saying to my wife that I think that in a funny sort of way, I think you should be able to buy the materials to make a bomb. It shouldn't be easy, but it should be possible.
La la la.
And it's not going to be possible to do it soon, let alone not easy. Yeah.
No. Well, yeah, the first challenge will be who takes cash?
Yeah. Or you just have to rob the shops to get the stuff.
You're recording this. You stopped recording this, haven't you, Steve?
I'm afraid not.
I don't care. I'll stand out in the middle of the university and say that.
Yeah. All right. So I just had a thought, and that I thought what we should do is every meeting we should have an award, which could just be a verbal one because that's all I've got to give you, for the best background. Now, Vincent's, I think the first Zoom meeting we had, I was very impressed with. So you get not a posthumous award, a retrospective award for that. But tonight would have to go to Don's. I like,
Yeah, that's
Don's,
good. Yeah.
I'm trying to think, are they actually really big books or is it a really small Don?
No, it's an image. That's what it is.
You see, I tried it on mine, but it just doesn't work because my background is so bitty. It's all just, it won't hold it together as an image.
I'm just wondering what that is. That looks like some drug smugglers loading up their Cessna 377.
Well, you're not so far off. It's a Cessna Skymaster.
Yeah. And
it's on an ex-American Air Force airstrip on the coast of Liberia.
There you go, drug smugglers.
Yeah.
It's just that particular airplane was really popular with drug smugglers.
Yeah, well, it's a fun airplane.
Yeah. Noisy though.
Yep.
All right. Well,
I have to change my my background for next time then. I'm a bit of an aviation enthusiast. So I used to fly, and fly model airplanes and that as well. So
yeah,
impressed with your background, Steve. I'll give that one to you.
Yeah, I like that one. Yeah.
All right.
Yeah.
All right. Well, that just about wraps it up. We've had just a very brief skim over the top of what Python can do and what Stephen can't do with Python. Yeah. All right. So. Hopefully we'll have the meeting again next month and we'll have something, a topic in a different vein. So stay safe, everyone, until then.
Okay.
Thanks,
Cheers.
Dave.
Thanks.